Today, we have someone that doesn't need introduction at all. Gavin Halliday has been part of the core HPCC systems team since before it was even called HPCC. He's been the driving force behind the large number of components of it, and perhaps the most prominent is the ECL compiler. Gavin is a computer scientist. He's been in the industry for a very long time, and I won't make numbers, so I don't divulge his age and my age. And he has really got into expert or highly expert level of understanding on compilers and distributed systems and cluster architectures. And it's really a pleasure to have Gavin here. He, as I said before, he's been doing this for a very long time. He has extreme knowledge of almost every component in the HP systems platform. And he has been also one of the driving forces behind this journey to HPCC on the cloud. All of this container-based and orchestration-based and dynamic nature of HPCC that you've seen as an evolution over the past few months is coming mostly from Gavin's head. So hello, Gavin, and it's a great pleasure to have you here.
Hi there. Hi, Flavio. Good to be with you. Yeah, I definitely don't feel like an expert as far as the cloud goes. I think it's been an interesting journey over the past few months, just trying to get our heads around how do we adopt or adapt this platform that is designed to run on lots of physical computers with reserved computers underneath them, and how do you get that going on the cloud, and how does that change everything? So yeah, I don't at all profess to be an expert, but definitely learning things as we go along the way.
Yeah, you're very humble. But Gavin, tell me a little bit more about we have had conversations already with Richard and Jake, and we covered a number of areas. But I think one of the areas that we left uncovered was all of the file storage aspects of HPCC in the cloud, and particularly in Kubernetes. All of the considerations that you need to make to access this storage distributed, index formats and other things. And certainly any of these things has performance implications. So we haven't covered any of those pieces either. So tell me a little bit more, if you've been working in these areas, what's there? What's in our current version and what is coming down the road?
Just turn that off. Well, so the first version, 7.8, really that's a proof of concept and the things that Richard and Jake have talked about, it was all about trying to get the structure right for building it and learning how people normally deploy systems and understanding Helm and Docker and trying to get some Helm files which fitted in with our system, but also matched what the industry would expect rather than trying to adapt what we've got already and just shoehorning it into it. And so they worked, but with those default Helm charts, when you brought a system up, it created some persistent volume claims, some places to store the data, but as soon as you uninstalled it, those disappeared again. So that's great if you're testing the system, because you can just start from a fresh system each time. But if you're actually trying to use it to do some real work, that's not actually very useful. So one of the things we've been working on is changing how that works. And in fact, in the recent versions of 7.8, we restructured those Helm charts a bit to separate out the way the storage is managed in a way that makes it easy to what we want to do is to be able to have you configuring the platforms in different ways, so running on your local machine or on a distributed cloud environment or an enormous system and have that configuration specified, but separately be able to say, okay, but my data is going to be stored either on Azure using their files, or using blobs, or on Amazon, or on Google Cloud, and they all need to configure the storage in subtly different ways. We wanted to be able to plug in different implementations of that storage into those Helm charts. So the recent 7.8.24 contains changes to the Helm charts that restructure it, but it also contains some examples which show, okay, if you're running on your local machine, how do I get persistent data in so that I can access, say, a directory on my laptop to contain my data so that when the system goes down, it's still there? Or similarly, if you're running on Azure or AWS, how do you get that data persistent? So that's been one of the recent challenges we've been looking at.
So I am extremely curious. That's a good starting point. But for the longest time, for 2 decades, we have been relying on storage that is distributed. So where no node has full view of the entire storage space other than through the API, the underlying API of the HPCC system, right? And I know that the cloud gives you the ability to have this sort of global shared storage. So is the idea of to keep those file parts still independent from each node? Is it the idea to merge them in some way? Is it the idea to interleave the access to these file parts across the different worker threads in the different Kubernetes pods? There seem to be so many possibilities there that it's.
Yeah. So. And I think there isn't a single answer either. So I think the idea of retaining separate file parts is going to stay, because that's a very useful granularity for both processing and writing out data files. If you've got 50 nodes generating data, you don't want them generating to a single file. You do want them generating to 50 different files. So that's true, but how that maps to the underlying file system really is debatable. So you could have it that all of the machines mounted one logical, like a NAS drive, effectively. They all just go through the same service and read data. Or you could have it that they each have a specific node or specific data storage item mounted onto them, so they can only access one part of it. Or you could mount 20 different storage nodes and the data gets spread over that in some way. So now the way we've done it at the moment effectively maps a single drive onto the local node, and they're all storing it in the same place. But further down the road, I definitely expect us to support other ways of doing it as well, because you may want it for throughput. Each of these storage devices has got limited throughput, so if you're maxing that out, you're going to have multiple ones being accessed from a single Thor cluster. And the different platform cloud providers have different functionality and characteristics on their storage devices as well. So Azure, for example, allows you to mount one that's accessible from multiple nodes. AWS, you don't. You might set up an NFS server instead that's got exclusive access, but the other nodes actually access it through the NFS server. So a different, and of course there's the other option which the different cloud providers have got of using blob storage, which works quite differently. So whether that's Azure blobs or AWS buckets, they don't have a filing system. they're not mapped as block storage or something like that on your local machine, and they've got a different API for accessing them. Now, the big reason for using them is cost. Generally, they cost half or a quarter the price of the other storage. So if you're storing large amounts of data volume, you want to be using it if you can, but they've got different characteristics. So how do we integrate those into the platform as well?
So that's very good. Okay, good. So let me just drill deeper into just one particular aspect of one of the functions of HPCC. And I'm thinking now of a Thor system that is trying to do a global sort. So nodes in the past used to handhold the other nodes when they were trying to, so they were looking at the data they have, and their own partition had data that was destined to some other node. So they would get the data in some place, then would collect the data from that place, try to communicate to the other node, transfer the data to the other node would receive that piece of data, and then eventually would put in some spill file that would be then used to build the final file in that partition for that one node. Now, if you have global storage, couldn't you just maybe come up with a different strategy instead of doing all of this work on the backend on the HPCC itself? Could you just push it to storage and just persist those pieces of data that correspond to different nodes somewhere else that the other node can pick it up when they need it, and you avoid creating those spill files?
You might be able to. I mean, the case of sort, I'm not sure you would actually do it differently, but yeah, there may be some operations that you might do differently. There are also reasons why you might not do it differently. So, so first of all, the possible example, and then why you might not. So say you're reading a data file and you then need to distribute it, maybe not with a sort, but just distribute it to different nodes. So you want to then do processing, grouped processing on that. You could, instead of reading the file parts locally and then sending them over the network, you could read all the file parts locally and filter out only the records you're interested in. Now, you might not actually want to do that. One reason's cost, that each time you access the data file you pay. I mean, it's a tiny amount, but if you're reading it 100 times more, then that's going to go up. The other reason is time, that even if it's got good caching, the fact that you'll be reading it from 100 places rather than one is going to put extra load on that storage server. So I think there are definitely places, and probably key joins or other things may be places where the fact that you can go directly to the file rather than having to go indirectly will speed things up. And similarly, if you've got complicated systems where you've got multiple DALIs set up like a production or multiple production systems, and you're trying to read data from one on another, then you don't have to go indirectly. You can just go directly to the data. Now, saying you can do that, that's in my head rather than in practice at the moment. So that's one of the areas that we need to keep working on is, okay, how do we get it so that that all works seamlessly behind the scenes?
It amazes me always how many considerations need to be taken into account when you are trying to design or redesign a very complex and large-scale system, right? Sometimes, a small tweaks here and there can produce vastly different results, good or bad, depending on how you touch them. Yes. So, but tell me more. So this opens another set of questions in my mind, which is all of the aspects around index files. So how will they work?
In some ways, that's a good question. So, well, they do just work at the moment. So we had, as the system stands, they do just work. Now, I've been working on storing all the data in blob file formats, and for that they don't quite just work, because when you're creating a blob, generally you have to do it by just appending data to the output. But most of the systems allow you to output it in chunks, but you can't go back and change some of the data. And the way we built indexes, there were a couple of different areas. One was the header on the front of the file gave you information about what was in it, but that's no good if you can't go back and change it. And the other thing is where you have blob fields within your indexes, the way they were written required you to go back. So we've had
I apologize. I was smiling a little bit because it reminded me of the log structure merge trees in Cassandra, right? Where they assume that they can only write sequentially over time. Yeah. And everything is an overlay of the previous thing.
Yeah. So, I mean, our indexes aren't dynamically updated, so we don't have a lot of the problems that you would have, say, in a MySQL database if you were implementing that. But there were a few issues. So those have been changed in 7.8 as well, so that you can now build indexes that don't require backpatching. I guess the other question then about index is to do with how they're used. So if you've got our index storage format is pretty old, so it is probably 20 years plus the basic code.
I wouldn't say old, I would say trusted. 35.
Okay. Okay. Our index code is, shall I say, mature. It works, and it works pretty well for what we use it for. But if you're storing your indexes on blobs, the fact that we typically read 8K at a time doesn't fit so well with the latency times that you'd expect reading data from blob formats. And it may even cause problems with data stored on faster disks connected. I mean, so once we've got the system that can really work well with blob data and with all the different kinds of connected disks and ephemeral disks and things like that, we need to actually do some benchmarking and testing to see, okay, if you're heavily using indexes, what works? So, I mean, one possibility is we could read more than 8K at a time. That would mean you're less likely to need to read more data, but you're probably also reading data that you're going to throw away more. Our current index format needs to decompress the pages before you process them. It'd be much better if we had a format, and it's something we've talked about lots of times in the past, having a format that you don't need to decompress first, you can actually process in place. And similarly, modern systems often use column storage, so they store all the different columns together. This could be a good opportunity to go back and revisit that. So I think one of the good things about moving to the cloud is it does pose lots of questions, and sometimes that can challenge the way that you're doing things already. And as you say, for the sort, you might think, oh, well, what happens if you do this? Similarly, for index reads, you might think, well, this works, but what would make it work really well? And I'm sure out of that, there are going to be some good changes to the functionality of the system, as well as just getting it onto the cloud.
But it doesn't, the cloud, maybe this is my naive view of it, but doesn't it reduce or eliminate some of the constraints that you used to have when you thought about physical systems? Because when you bought a computer to use it as a node, you would buy a computer that comes with a certain amount of RAM, a certain amount of storage, and a number of CPU cores, and those all come together. and you have them, you use them or not. So in the cloud, you can pretty much provision each one of these in semi-independently. So I think, but in my naive thinking, it gives you more freedom, right, to design things the way you want them.
Yeah, it can, and you don't have any restrictions as long as you've got an infinite budget. And
oh, good point. Okay, you need to optimize for cost. Yes.
So if you're paying, then I've got no problems at all. But
yes, you are absolutely right.
Often, I think with the cloud, it probably is down to a trade-off between performance and how much is it going to cost. So that's definitely a trade-off on where you store your data. If you didn't care about the cost, you wouldn't use the blob storage. And similarly with the characteristics of the nodes that you use for Thor. But you're right, it does give you flexibility. So for instance, if you're doing some machine learning and want GPUs to handle that processing, then the cloud does enable you to just use GPUs on that workload. And we, I think by version 8, we will have it set up so that you can configure a system to say, okay, this is a Thor that you use if you're doing work that requires GPU, things like that. So it does give lots of flexibility.
Oh, wow. Now I think you opened my eyes. So you could say, I have this work unit. Since we are going to be spawning Thors dynamically, you could say, well, this work unit requires GPUs. Let's spawn a version of Thor that has GPUs built in. And we pay only for that version of nodes in this particular work unit for this instance of Thor. The next work unit might not require that, so it will spawn in normal version. Some work units might require more RAM. Are you thinking in this along these lines?
Yeah, definitely on the GPU characteristics. And the same thing would go for the RAM as well. So Kubernetes has got the idea of node pools. So you can say, okay, I've got this type, say, a fairly lightweight node, which might be useful for running things like ECL agent or some other processes that don't require much. Then you could have a node pool of units that have lots of memory, which might be useful for DALI and Thor. And you might have others that have got GPUs, and then you can use labels on the nodes and restrictions on how the things get allocated to tie those together. So that, yeah, I think you should be able to do exactly what you want.
Wow.
Now, maybe not full flexibility in the first version, but I think the capabilities are there, and we should be able to build on them.
So I know that by 7.8.24, which is the current version, we have test system, right? A version that can allow you to do some testing, but it's not meant to be fully production ready. So what's the full production ready version for these capabilities? Is it going to be 7.10 or 8.0? What do you think?
Well, I think 7.10 is coming out in 2 weeks' time or so. So
probably not.
I mean, so we've got some form of persistence in 7.8. 7.10, I think it would be good if you could actually store your data in blobs, probably just on Azure in the first place, but we'll probably put AWS in as an incremental point release to 7.10. There's quite a lot of underlying work that needs to happen to be able to really flexibly support the different kinds of file storage. So it could be that you have a Thor where some of the files you want to build go on blob storage, others go on faster storage, others go on SSDs, partly depending on how they're then going to be used. So if they're going to be used by Roxy, then you may want it stored one place and not on blob. So to provide that flexibility, that's going to require some work. So I'd expect that to come in 7.12. And I think 7.12, you should be be seeing most of the pieces in place, and they'll be suitable for getting a system up, testing it, and really pushing it, but probably not going to production. And I think our plan is for version 8 to be kind of the first one we consider is really worth going to production in.
So now the critical question. So are we going to call it version 8 or is it going to be HPCC XP? I'm just kidding. It's okay.
Version Y, yeah.
Yes. I don't know. Hey, this was very good, Gavin. I really, really enjoyed this conversation. So plenty of things coming. As well, there are some things already available now, plenty of things coming down the road, and certainly a myriad of considerations that need to be made. I can imagine some of those off-site meetings that your team has, how they they go over all of this, right? Brainstorming and trying to come up with the best strategy.
Yeah, not so many offsites at the moment, though, unfortunately.
I know. At some point, yeah. Unfortunately, the COVID times are really weird times for everyone.
Yeah.
Great. Thank you very much, Gavin. Gavin, this was great, and I'm sure we will be talking again soon. Thank you.
Okay. Thank you.
Thank you.